In the vast expanse of our solar system, beyond Mars and the asteroid belt, lies Jupiter, king of the planets. And orbiting this gas giant is Europa, one of the most intriguing moons in our cosmic neighborhood. Scientists believe that beneath Europa's thick icy shell, there may be an ocean that could potentially harbor life. NASA has embarked on an ambitious journey to unravel Europa's secrets. This is the story of the Europa Clipper mission, a spacecraft designed to explore this icy world and search for conditions suitable for life. Every great mission starts with an idea. Before Europa Clipper, NASA explored various mission concepts: a lander, an orbiter, and even a spacecraft that would fly in resonance with Europa's orbit. Ultimately, a multiple flyby mission was chosen for its strong science potential, lower cost, and reduced radiation exposure. To unlock Europa's mysteries, the spacecraft needed the best tools. NASA selected 9 state-of-the-art science instruments: cameras to capture high-resolution images, spectrometers to analyze surface composition, a magnetometer to study Europa's magnetic field, and an ice-penetrating radar to peer beneath the frozen crust. With instruments chosen, the mission entered the design phase. Engineers built and tested critical components, including solar cells capable of operating in Jupiter's harsh radiation environment. Vendors were selected and prototypes took shape. As the mission took form, it needed a name. Drawing inspiration from 19th-century clipper ships, known for their speed and agility, the spacecraft was officially named Europa Clipper. With the final designs approved, fabrication began. Components arrived from institutions across the US and Europe. At NASA's Jet Propulsion Laboratory in California, engineers carefully assembled the spacecraft, ensuring each piece met rigorous standards. When completed, the Europa Clipper would be larger than an SUV, with solar arrays spanning a basketball court. With assembly complete, Europa Clipper was ready for its journey to NASA's Kennedy Space Center in Florida. Here, final tests were conducted, and the spacecraft was integrated with its launch vehicle, a SpaceX Falcon Heavy rocket. The world watches as the final countdown begins. On October 14, 2024, the engines roar to life. Europa Clipper blasts off, beginning its years-long voyage to Jupiter. Beneath the icy crust of Jupiter's moon Europa lies a hidden world, an ocean, vast and mysterious, stretching deeper than any on Earth. Could this alien sea harbor life? NASA's Europa Clipper mission is on its way to find out. To reach Europa, the spacecraft must first enter Jupiter's orbit. Using its engines as brakes, Europa Clipper will take about 6 hours to slow down, a long but crucial maneuver. It will even fly by Jupiter's largest moon, Ganymede, as part of this process. But the journey doesn't stop there. Europa Clipper will use multiple flybys of Jupiter's Galilean moons, including Ganymede, to carefully adjust its orbit for repeated close encounters with Europa. Scientists believe Europa holds a global ocean beneath its frozen surface, up to 100 miles deep, containing more water than all of Earth's oceans combined. But how do we know it's there? Europa Clipper will confirm its existence and unlock its secrets. As the spacecraft settles into its mission, it will make its first close flyby of Europa, collecting initial high-resolution images and data to help shape its orbit. This will be the first ever close-up view of Europa in over 2 decades. Europa Clipper is equipped with a suite of advanced instruments. The Europa Clipper magnetometer, or ECM, will measure the moon's magnetic field, revealing the ocean's depth and salinity. The plasma instrument for magnetic sounding, or PIMS, will separate space plasma noise from ocean signals, ensuring precise data. Gravity measurements will track how Europa flexes under Jupiter's immense pull, shedding light on its internal structure. And the surface dust analyzer, SUDA, will catch tiny particles ejected from the surface, offering a glimpse into Europa's chemistry. The mission is divided into 2 main science campaigns. In the first phase, Europa Clipper will focus on the anti-Jovian side of Europa, the hemisphere facing away from Jupiter. Instruments will gather data on the subsurface ocean, icy shell, and thin atmosphere, with flybys as low as 16 miles above the surface. In the second phase, Europa Clipper will shift its flybys to the subjovian hemisphere, the side facing Jupiter, continuing its exploration with a full suite of instruments. Europa's rocky interior and iron-rich core could be crucial to life. Heated by tidal forces from Jupiter, hydrothermal vents may be pumping nutrients into the ocean, just like the deep-sea vents on Earth that support life without sunlight. If simple organisms exist on Europa, they might thrive in such environments. The mass spectrometer for planetary exploration will sniff out molecules from the ocean, searching for the building blocks of life. And the mapping imaging spectrometer for Europa, MICE, will reveal the distribution of key minerals and organics across Europa's surface. Once its mission is complete, Europa Clipper may conclude its journey by deorbiting into the surface of Ganymede, a planned impact that ensures the spacecraft won't accidentally contaminate Europa with Earth microbes. Are we alone in the universe? Europa Clipper may bring us one step closer to the answer. Stay tuned for more discoveries as we journey through Voyager in space. Let us know in the comments. Like and subscribe for more space discoveries. Do you think Europa's ocean could hold life?